Hello everyone, I had a dream to make my very own bare minimum neural net to play the plausible game of Go for a long time. Well, basically since somewhere around 2015 where the AlphaGo appeared out there. But I didn't have enough knowledge, enough understanding and enough skill to make that a real project. So within the last few weeks I've been studying deep learning quite a lot, and eventually I came up with my very own model that plays the plausible game of Go. So in this video I'd like to demonstrate how that works and maybe a bit of the source code to give an idea that it's not that complicated as it might seem. So when we think of Katago, that's the very deep and very complicated net, and it takes ages to train one at home. But if we simplify the net architecture, and if the dataset is not as huge as with Katago, with Katago, it's not even the matter of supervised training. Obviously, that's the reinforcement learning. But I thought that maybe just the bare supervised learning, like they did back in the day with AlphaGo, might be a bit simpler, easier, and just the way to go for me, because I really wanted to try some supervised learning, not the reinforcement one. So I downloaded 5,000 Pro games, actually downloaded more, used 5,000 to make the dataset. So the input to the net is that simple. It only has two channels, like one for black stones, one for white stones. Like for comparison, Katago has around 17 or maybe 21 or something. So it also has like liberties, a lot of things, really a lot of things as input features. Ladders also, yeah. So this is a very simple model, just black stones and white stones. And then I only have a few convolutional layers. And just to give a quick clue why the convolutional layers and what are the convolutional layers. So the idea is simple. The convolutional layers is something that helps working with the two-dimensional data, like the board, or it's also used for the image recognition. So the idea is that we want to preserve the spatial relationships between the elements within the input data. And that's the reason why we use the two-dimensional convolution net. And imagine a nested for loop, so like looping over the rows, looping over the columns, and then we have the 3x3 kernel there that is inspecting the data, like 3, 3 here, 3, 3 here, 3, 3 here, and then just going lower, 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 and it just inspects, scans the whole board. And that's how it adjusts its own weights, and that's how it knows what is good in Game of Go, what is bad, and how to proceed. So it doesn't have skip connections like residual connections, because the net is not that deep and the gradients are not vanishing yet, so this is like quite small enough. It's a fully connected convolutional net. Because of no compression and no optimization for size, it's just like 50 megabytes or something. Eventually, the training file, but also it also contains the optimized data. So if we strip this down only for inference, it would probably be even smaller. So the training loop is very simple and straightforward. Yeah. So just using the SMW optimizer here. The cross entropy loss to get one of 361 possible outcomes. Those are the largest that we have to score every single square on board. And also preparing the dataset, just a file that uses SGF-MIL to process the games and write to the PyTorch specific PT file eventually, the output file, and then using the data loader within the train loop itself. It just loads data in batches and trains. So overall training took 4 hours. The eventual loss I got was 2.1. It's not that good, I know, it could have been better. This is on the training set only. I didn't use any validation because like validation is like how I see how it plays, I would say. And it eventually reached around 15Q, I would say, level. I'll show in the video in this one how I measured this strength. So it's very imbalanced. When it comes to the opening, it plays like 1Q or even 1 done maybe sometimes. So quite strong in the opening. But then when it comes to tactical complications, obviously just doesn't understand what should have been done. But generally, if an absolute beginner plays against this kind of net, he might feel even smashed, yeah, because if you're slow, if you're not doing much, then you may end up like computer would take all the territories, yeah, build a huge boy, for example. We'll try to cover that as well. So, this is the first initial run, and I will probably try some more complicated architectures for the NAT so that it trains probably not 4 hours, but maybe 8 hours, maybe 12 hours, maybe a couple of days, I don't know. And so that maybe it can beat me at very least. I'm around 6Q. Okay, so without further ado, let's have a look at the NAT in action. I would upload the NAT so that to the release page so that you can also give it a try. It's not uploaded yet by the time of recording this video. So TinyGoCNN, yeah, probably worth mentioning is to how to make it. So the current working directory is specified here. So this is where the project lives, and then just using Python to run the gtp.py. So that's how I do things. Right. I was actually doing this in the virtual environment when I was developing, but with the Go GUI, I'm not quite sure how to use the virtual environment. So I'm using just the global environment, which fortunately has all the dependencies as well. So by torching things, NumPy. Okay. So let's attach this one. And the first experiment would be just want to run the Selfplay. So computer, both. What is this? Okay, yeah, hold on a sec. I've been testing something. I've been testing something and broke something. Okay, you don't want to print the tensor shape. Okay, now I need to. Okay, now I need to start over. So let's try again. Attempt number 2. Okay, now it plays against itself. Initially, I was trying this without the move legality checking, but that ended up in falling into co. Yeah. So I used the code from some experimental Python implementations of the rules, like the Gakuse engine in particular that I've been making. I've probably been covering here on YouTube as well. So that handles the co and all the illegal moves, all this stuff. So yeah, black is doing much better here. Okay, if white play here, he would live. If not, he would die. But yeah, this is how the game looks. I just want to scroll back to the beginning. Maybe I would just probably save so that I could evaluate this with the Katago UI estimator a bit later. For now, I just want to go to the beginning. So this is how it starts. So reasonable opening so far. Well, I'm not quite sure about this move. So maybe follow up here for Ijisaki or from this side. But this also makes sense. This goes like a Chinese style opening, which kind of possible. And again, so here, because didn't play, didn't play earlier. Okay, yeah. So next move is Joseki move over in here for blacks. So white already prevents that, which is interesting, and black tries to deal with that. Well, I'm not quite sure about this extension. I'll probably play here, threatening to connect, and then maybe I don't know. Maybe that's a bad idea. Then maybe here. So like at this moment, it's very logical. So black is potentially trying to surround the white group. So it's absolutely logical. So if white is trying to escape, well, this might be a little bit too slow, probably. Yeah, it feels like it makes sense. Yep. Okay. Well, this is like really too slow. Obviously, just maybe can like protect this cut somehow because white group is like becomes really weak here. So this move like weird as well as this one. This is too slow. Better just take somewhere like corner enclosure approach, invasion approach from this side. Yeah, so it's not that good from here, but you see like black is protecting the corner territory and growing quite huge in the corner. Okay, so white is threatening the cut. This might lead to a disaster, so black protects. So it's quite a thoughtful and plausible game of Go. Well, obviously, yeah. Well, yeah, again, like, this is the very classical for the double-digit cube players. You see, like, just trying to build the wall. One opponent builds the wall, another just blocks. It's a very curious game here. And again, just preventing black from invading there. So everyone builds on his own. Well, black is definitely much bigger here, so white needs to invade. Yeah, but it's not going very... Yeah, again, here, it's just a run move. He should have played this, here, and then he's just alive there. This is just run. Yeah, this is just run. Although he could still live as it showed up later in the game, but yeah, so this is like slow and not to the point. Yeah, so black is trying to reduce white even more. And by the way, this group might die if not careful, yeah. This group might die. But yeah, black is just right in time to build 2 eyes. Yeah, I think it's alive now. I think it's fairly alive now. So yeah, not very smart from both sides, but we have this attitude, I would say. We have this direction towards like a reasonable play. And yeah, this has been played, or this has been trained on pro games, so no surprise that lots of fancy concepts has been learned, and also lots of basic concepts has been learned as well. Okay, so I start the estimator, and let's see how this particular game is going to be evaluated. So again, for those who didn't follow previous videos, maybe how this estimator works. So this number is Katago move choice. So move number 1 is like the best Katago move. Move number like what we have here, like 110, that means not very good move. And then it takes the mean of that. And it says that the black has been playing as 14Q and the white has been playing as 24th Q. So again, depending on position, it might give different scores. So maybe a very quick example. So if we let it play, say sanrensei, so none. Let it play sanrensei. And I would also need to manually adjust a little bit the okay, later. So again, Looks like a meaningful sanrensei game. Yeah, white is. I hope white is. Yeah, white is alive now. Yeah. So white tried to destroy black. I think white is doing much better now. Yeah. Yeah, white is doing fantastically great killing the group. Yeah, cool. White is doing really good here. Okay. Save. Save. Replace, and it's not gonna work out of the box because I need. Oh my goodness! Here is this. Here it is. I need to specify dummy inputs for player black and player white. Now this should work. Okay. So the scores will be quite different now, I believe. I think, yeah, this game looks to make more sense than the previous one, although the previous one is also good. But if we give it a starting position, it might result like in different. So 20, 25Q, yeah, not as good, maybe not as good, but yeah. So it's very noisy still. Lots of mistakes for both sides, essentially. All right. I want to quickly show you how I play against this as a 6Q human player. So, new game. I'll probably just show you the intermediate in between evaluations so that making it clear. So, like, he plays Joseki quite nicely, and at this point, he's doing quite good, I think. I think he's doing quite good. Yeah, taking the corner. Well, it's a bit old school. So these days, probably approaching from this side, but maybe the training data I have doesn't have enough modern games like from 2000 to 2017, something like that. So it's very very at this point. So let's say, yeah, but here he knows the Joseki, you see. Here he knows this. So at this point, well, I think that white is doing quite nicely. Let's check this with Katago. So I just want to save the position. Game SGF, save, replace. I want to set the black player dummy because Katago estimator I made is not going to work otherwise, because SGF mail it relies on needs to have the white and black player to be passed. So it's very flattering to me. So I was evaluated as 5 done. I'm just 6Q. I'm not a 5 done. So at this point, computer. So the model that I train is like 4Q, which is solid enough. So only because of this. So there was one move that wasn't really good. Which one move? Somewhere around move number 15. Not sure which one that is. Yeah. Well, but from the human perspective, I think this is just not bad at all. So, yeah, let's keep playing. Just a few more moves. I just want to show you the weak points. Not going to be finishing the game to the end because the computer would just collapse quite soon, and no particular reason to finish the game. So what can I do? So can I somehow... Okay, he lets me cut. So yeah, he tries to make a base, but he just lets me cut. This is not good. This is not good. And okay, is he going to tactically... Okay. Oh, really? Gonna kill me, man? He is going to kill me, yep. Is he going to kill me? Okay, so tactical disaster, you see? He could kill me there easily. So all goes like this. So this is a stupid move, I know. This is even more stupid move. Nope. Okay, so he's trying to kill somehow, which is interesting, yeah. But again, you see, like, he doesn't see this. So just trying to give him a bit more of a chance. But no mercy, yeah, just kill it. So something that would never actually work against the, yeah, you see, it just blunders tactically a lot. So I can probably even try to, nope, can I kill? Nope, I cannot. Okay, yeah, so at very least it kills this, which is good. Which is good, which is good. Yeah, so like I can just, yeah, this is super inefficient, but oh, he's trying to kill my corner. Whoa, can you believe? Is he really going to kill my corner here? I think he could play here and just kill my corner. I think he could do that. I think he could do that fairly. Okay. Yeah, is he like very vulnerable to tactics? Very vulnerable to tactics. All right. Yeah, just, yeah, but that's the price. That's the trade-off for the shallow network, and very poor input features as well. So yeah, I would say this architecture is a very simplified architecture of the one that is available within the patchy network, the dead left network that has been used there. Not the 54%, but the 44%. That's called the 44% net. Well, I think it's quite clear that the game is pretty much ended here. I'm playing the moose. I would never ever play against human players. Nearly dying, could potentially die in the corner. Yeah. Okay, just another blunder by him. Just another blunder. Okay, this one I'm not gonna kill. Okay, yeah, he's so blind. He is so blind, yeah. Alright. Yeah, it's like, yeah, like bitten a child, essentially. But, this is interesting anyway. Yep. I just want to finish the game. I thought I'm not gonna be finishing the game, but I want to finish the game. Just kill everything. Yeah, yeah. Okay, maybe I can pass already. I wonder, is it going to collapse when I pass? Nope. Okay, now he passed. Alright, I'm not sure if this is going to be working with, because of the pass, it might not be properly working with my script. I'm not sure, let me just quickly check this out. Save as SGF, save, replace. Okay. Fingers crossed, let's try to evaluate this one. So yeah, not very strong, I would say. Not very strong. So obvious tactical mistakes, but it has a clue. I think it plays the plausible game of Go. Like, it makes perfect sense. And again, for those who's just starting with the game, this already might be like a decent opponent to play with. Whoa! 18Q! Whoa, that's amazing. That's amazing result for him. I was only 14Q. So according to Katago, I wasn't really that much different with this. Not much better playing player than this net. According to Katago, yeah. Sometimes it gives me a bigger score, but yeah, this game, not very big score. So yeah. So this 18Q. So when you play online against, like, I don't know, real world 6Qs, it might often have this evaluation from Katago. Very least on the PlayOK website where I usually play Go. So yeah, this is it. This is it. So I don't know. Potentially, I may try to complicate the model. Yeah, give it a bit more time to train, and ideally, I want to come up with a net that would be capable of beating me, or at very least playing like 50% win rate against me. That's the best ever thing to have. So maybe I would be capable to achieve that as well. I just want the absolute bare minimum that I want to keep is just 2 input channels, so no fancy things like no liberties, no no ladders, no co. So just the bare position, but maybe just increasing the number of layers. Again, I'll probably try to reproduce the so-called dead left network. I probably don't have it anymore. Yeah, I don't have it anymore. But so that's just a whole lot of convolutional layers, and I'm not sure if they are all fully connected or not. So yeah, I need to check this out basically. But for now, this feels really, really okay. So guys, this is it from my side. Thanks for watching, and hope to see you in the next video where potentially I can come up with a stronger net.